There are two types of numbers.
Prime numbers.
We're going to talk about what a prime and what a composite. Okay, every number can be classified as such, either prime or composite. And we're going to just focus on positive because it's basically the same concept for negative. But usually we just talk about positive numbers. So prime and composite. Thing down. Before we learn about prime and composite, let's look at this word, factors. Factors of a number are numbers that multiply to give you that number back. It's important to realize that a lot of numbers have more than two factors, right? For example, 100 could be 50 times 2 or 10 times 10, right? Or 25 times 4. 100 times 1. Every number has two factors, itself and 1, okay? But some numbers have more than that, and that's the difference between prime and composite. But for an example, 20, and yes, you need to write this down, please, for your own sake. 20 has at least 3 groups of factors. In fact, I think that's it. It has 10 and 2. That's one pair of factors. Yes? That's a 5. I'm sorry. My handwriting is not perfect. 20 has 2 factors, 5 times 4. And it also has a third pair of factors, 20 times 1. All of those are factors of 20. So you could say that 4 is a factor of 20 by itself, right? And I guess if you wanted to count the individual factors, you'd have 1, 2, 3, 4, 5, 6. So 20 has 6 factors total. Every number has at least 2 factors, itself at 1. You need to go back up? So again, make sure you write down every number has at least 2 factors, itself at 1. All right. A prime number, the only factors of a prime number are itself and 1. So every number has a factor of itself and 1. But if those are the only factors, then it's prime. So here's some example of prime numbers. Now, what's kind of crazy about this is, especially when you get to really, really big numbers, sometimes it's really hard to figure out if it's prime or not. I mean, if I just sounded off a number, say 3,443, for me even, like, I can't really look at that number and necessarily know without really testing a bunch of numbers to see if it goes into. But for smaller numbers, especially if you know your timetables, we should be able to figure it out. For example, 101. You can try some stuff out, like 11 looks like it might go into it, right? But it doesn't. Of course, no odd number can be divided by 2, right? So we know 2 doesn't go into 101. You can try some different things out, but a lot of it's knowing your timetables. Basically, for 101, it's only got 2 factors, 101 and 1, so it makes it prime. 7 is obvious. It's a small number. We know 2, 3, 4 don't go into it, right? Only 7 and 1. Here's a few other examples. 13. And then I came up with one that was a little bit bigger. 191. What numbers would you try for 191 to see if it goes into it? Maybe 11 or something that ends with 1, right? Maybe 21, right? But that doesn't work. 21 times 8 would be like 168. So it's not always obvious, but when it's less than 200, you should know your times tables well enough to know if it's prime or not. Somebody raise your hand and give me another example of a prime number. Raise your hand. Dawson. 11. Anybody else? Give me a prime number that's bigger than 100, but less than 200.
121.
121? Nope, that's 11 times 11. 107, I think you're right. 117, 3 goes into that. Good guess. But on the flip side, we have composite number. Any number that's not a prime must be composite. So it has factors other than itself and 1. Yeah.
Other than itself and 1.
So 10 times 1 is itself, but so is 5 times 2. So as long as it has other factors other than itself and 1, it's composite. Yes?
Is this where you end up getting like the
We will eventually do some factors. Another example, 24 is a composite number because 8 times 3, 12 times 2 also, right? 6 times 4, it's got a bunch of factors. 45, 15 times 3. Again, these also have, 45 also has 45 times 1. 91 is one of my favorites. It definitely looks like a prime, but it's not. 13 times 7. I'll give you guys a second to get this down. So all even numbers have to be composite because they are divisible by 2, except for 2 because it only has 2 factors. But just realize that to factor a number, it is helpful to know your times table. In other words, if I wanted to know if 49 was a prime or not, if I knew 7 times 7 was 49, that answers the question, right? So knowing your times table is important. And this is the way I was taught, normally up to 12 times 12. We will be going up to probably numbers up to 200. So you would need to know up to 14 times 14, which is 196. 13 times 13 is 169. So all of these numbers on this entire chart are all composite numbers, right? They all have factors. If it's in a times table, then it's a composite number. 70 is a composite number, 10 times 7. 25 is a composite number, 5 times 5. So on and so forth. So if a number doesn't show up in your times tables, it's less than 200, that must mean it's a prime number. Okay. What are the factors of the following number? And is it prime or composite? Raise your hand if you got 2 factors for 36. There's more than one answer here. Raise your hand if you got 2 factors for 36. Yes. Good. Okay, so 6 is one factor. Any other answers? 3 and what? Good. 3 and 12. I'm thinking of some more. Yes. Huh? Okay. He's right. 1 and 36. They are, yes, 9 and what?
9 and 4.
Yeah, you got 2 more. Yeah, let's slow down for a second. 9 and 4. Two times what? Good. I think we have them all. So is it prime or composite? Definitely composite, right? I mean, it has a bunch of. That's why. I'll give you guys a second to copy this down. That's actually why there's 360 degrees in a circle. Part of the reason is because the number 36 or the number 360 has a lot of different factors. You can divide it a lot of different ways, which means you can take a circle and divide it into a lot of different pieces because it has so many factors. Next example, what are the factors of 17 and is it prime or composite? 17 times 1, anything else? So if there's nothing else, then it is prime. Yep. Next example, 300. Let's go ahead and just start listing those out. 10 times 10, 5 times 20, 25 times 4, right? 4 quarters and $1. 50 times 2. If it's even, you know that 2 is going to be a factor. Any others? So right now we got 10, we got 5, we got 20, we got 25, 4, 50, and 2. I'm missing 2. I just realized that.
Well, what 2 are you missing?
100 times 1, yeah. Shh. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. So is it prime or composite? 2. It's even, but what are the factors? 2 and 1, right? That's it. So that means it must be
Prime.
prime. Hold on, last example. 169. It looks like a prime, but I kind of just talked about this one. 3 would not go into it because 1 plus 6 is 7 plus 9 is 16, and 3 does not go into that. This one is actually 13 times 13, so know your times tables up to 14. So since, and also, yeah, don't forget 169 times 1. So it has 3 factors, and therefore it's composite.